Thank you very much. So, as Kurt said, we have a lot of adversaries these days at the ACLU. We have a lot of battles going on, and I spend a lot of my time fighting. But my talk today is actually not so much about adversaries, but about allies, and the ways that engineers, computer and software engineers in particular, and lawyers can really be partners in drafting and creating laws that actually protect our rights and that accomplish what they're supposed to do. So the idea came from, how do we do legislative engineering? How can we write laws that actually work, that incorporate some of the engineering principles and techniques into the process of creating laws? And it starts with a very simple concept, which is that law is code. You're used to working in the coding environment with software, but law operates in very much similar ways. It's a set of instructions about running on a certain platform, a judge, a context, a legal background. It takes inputs, the situation, the environment, the facts of the case, and it generates outputs and results. This is not very different from the code that we're used to in the computer world. Law also has some of the same flaws as bad code in a lot of cases. It has authors of radically different skill levels. There are hidden and competing priorities underlying what's happening there. It may well be unclear and undocumented. It almost always is unclear and undocumented. That could improve. It's often poorly tested. Someone has an idea of what this should do, but hasn't even bothered really thinking through whether it operates that way. And it may well have unintended side effects. In fact, law and code actually share something else, which is that we use food metaphors to explain when things are going wrong. In the software world, it's spaghetti code. You have all of these references and all of these connections, and it is almost impossible to parse what the heck is going on. In the legal world, we of course have sausage making, where you take all of these competing things and you grind them up, and what comes out kind of resembles what you started with. You would think that if you put spaghetti and sausage together, you'd get a wonderful combination. The reality is it doesn't quite work that way. You have the worst of both worlds. You have something that is confusing by lack of design, and sometimes confusing by intent, where the goal of the legislation is to accomplish things that are not immediately apparent, to slide some benefits to an industry that happens to be donating to a senator, to undermine transparency and accountability for law enforcement agents, for all sorts of things. So we have real concerns about the fact that the lack of engineering, the lack of real thoughtful design in law can lead to harms. The other way that law resembles code, and this is particularly relevant in the technology space, is that law doesn't age very well. Old law is legacy code. It was written years, maybe decades ago, in a completely different technological environment, and yet it often assumes understandings, definitions that are locked in based on how the world worked then. And yet now we are struggling to apply, to work with, to implement on top of existing laws, and that can be a real struggle. So I'll take one example that I've worked with a lot that some of you in the room may know. This is the Electronic Communication Privacy Act. This is a law that governs when the government can demand or when companies can voluntarily disclose electronic information that is stored with a service provider. It's wordy, it's verbose, it's legalese, do not bother reading this. The point is, if you break this down, you can actually come up with something that resembles code. You can come out with something that, here's how ECPA works. Is a warrant required? Well, it's required if you're coming from an electronic communication service and you're looking for content, and this information is in electronic storage, and it was created less than 180 days ago. So you can actually break down a law, look at it, analyze it, and write into something that looks like code. That doesn't actually look like that bad of code. If you look at it, it's it's logic, it's Boolean, it's just a bunch of ands, not hard. The problem, sorry, I'm going too far away. The problem is that it's really bad when you look at what it's actually doing, because it is embedding concepts from when the law was written, which was 1986. So when you think about email in 1986, I put this up here. This is actually wrong. AOL didn't even exist until 1991. So we're talking about CompuServe and other BBSs. But the way email basically functioned was that if you wanted to send someone an email, you logged in on your 1200 baud modem, or 2400 if you were rich. You fired off your email. It went into the ether, and it sat on their service until they actually logged in, at which point they would download the email and delete it from the server. And so, of course, at that time, if an email was left on a server, it was abandoned. It was like the trash you put out on the curb. So why would you bother protecting it? That made some sense then, maybe. It makes absolutely no sense today. And it leads to incredibly convoluted systems where email does not have the kind of protection you would expect under this law because it is anchored in all of these outdated definitions, archaic technology uses that simply are not like Gmail or any modern email system where for the vast majority of users, you never delete anything, in part because it's more secure in the cloud than it is on your laptop or your phone or anywhere else, in part because you can access it everywhere if it's still on the server, all sorts of reasons, but the point being, in a different technological environment, this old law breaks, basically. So the question is, okay, so we have law, and it does in some ways resemble code. What can we do as engineers? How can we use engineering thinking, practices, techniques to make better law? How can we help lawmakers make better laws? And I get to be both. I spend a lot of time writing legislation and working on it, but how can we implement practices and tools that can really robustly change the system so that we have better laws? And I'm gonna step back and say better to me means two different things. One is the very objective, you can figure out what this law does and it's predictable. It's good code in the sense of it is actually readable, someone else can pick it up and figure out what's happening, you're going to get reliable outputs. The second part is of course the policy outcome. Is this actually the outcome I want? But if I'm advocating for a specific outcome, if I want to make sure that certain groups are protected, I have to be able to know how the law is actually going to operate in the first place. So I can't even get to a positive policy outcome if I don't have a good law in front of me to work with. The problem, of course, is that I'm thinking about all these practices, and I was an engineer a long time ago. I thought there were like 2 or 3, maybe 6 or 7 software terms that I could throw in. There are more than that. But I've tried to think about my experience with drafting legislation, with working on this, and figure out what kind of software approaches can really work. And my context for this was working with CalACPA. CalACPA is the California Electronic Communication Privacy Act. This was enacted in California at the beginning of 2016, and it's a bill I spent a lot of time working on the language of. I would love to say I approached it with all these principles in mind. That's not really true. I had ingrained some of these from past experience, and as I look back on it, I realize some of them I did unconsciously fairly well, some of them I did not do unconsciously fairly well, and I would like to do a better job next time. So this was very much the inspiration for this idea rather than a model of how to do it perfectly, unfortunately. The California Electronic Communications Privacy Act was written as a supplement to an amendment of an update of the Electronic Communication Privacy Act. And it was written to be much simpler. It is very simple as to whether or not a warrant is required if you are a law enforcement officer in California. If you're looking for electronic communication information, the answer is yes. That's simpler, good. If you notice, it changes something. It is changing what it sits side by side with, but it is different from federal law in that the scope is not content, the scope is any electronic communication information. That has its own definition, because we've, of course, made a brand new standard, which is the right way for the world to work, and everyone will adopt it. Yes? No? No, probably not. So one of the challenges we always have when writing laws is, when is it worth reinventing the wheel? When are we just going to make things more complicated? In this case, we decided we really needed to do something different because a law that doesn't protect location information, that doesn't protect associational information, needs to be updated. We can't just wipe it out and start from scratch. We don't have that power. It's very hard to convince lawmakers ever to say, oh, that law we passed 6 years ago, that was crap. Let's get rid of it and start over. But we can do our best to figure out how to implement better standards. But sometimes it's just going to lead to proliferation and more confusion. How to master that, working on. So I've been looking back at CalACPA, at my experience with drafting this, and thinking about what have I learned? What kind of software engineering practices and techniques were really helpful? What really works in the legislative engineering, in the writing of legal code world? And then what would have helped? What was missing? What didn't I do? Or especially what kind of resources did I not have that would have been really handy then and would be handy going forward? And how can I draw those from the software engineering computer science world. There were a lot of software techniques that work actually very well in the legal drafting context. Specification, knowing exactly what you're going to do and what the outcomes are intended to be before you start. Wonderful idea. Not always how it works. Wonderful idea. Abstraction, trying to pull concepts apart instead of embedding everything in every single piece. Modularity, having different components that do different things, having a bill that isn't trying to have one big massive paragraph that does everything, but splitting reporting and notice and constraints into different segments. From a policy side, that actually is a mixed bag, I will confess. In CalECPA, we actually had a long section that was nicely carved out in modular on reporting. Every time you did something in another section, it triggered a reporting requirement. That made it very easy for some of our opponents to say, we don't like that. Can you just get rid of that whole section? And since it was neat and modular, it was easy to excise. Trade-offs are always going to be there in any of these principles, but it still helps in terms of just making it better, making it more understandable what the heck is going on, and how do the different pieces interact. Readability is good. Readability is hard. Readability in legalese where you are dealing with difficult concepts is probably an unattainable perfection. But you can do better than what current law does. And then robustness, thinking about how do we draft things that are not so tied to the modern executing environment, the modern technological world. I mean, especially in technology, but in other ways too, where we're not constrained to our current conception of, civil rights or whatever it may be, but can have a law that is adaptable, that is going to evolve with our society as time goes on. So these are kind of ideas that I would love to see embedded in more laws, and things that I will work on doing that. But what's missing really are the tools to make this happen and the tools to evaluate and analyze what's going on so that when you're coming up with a new legislative idea or someone else has come up with a new legislative idea, you're able to not recreate the wheel, not rebuild from scratch all of the information that I have in my head or some expert has in their head, but actually have things that you can use. And I really want, and these have to be tools and resources for lawyers. So it can't be a full, robust IDE that nobody can use. It has to be something that a lawyer can use, which dumbs it down a little bit. So one of the things that I think is really important is to do more modeling and mapping, to really start fleshing out, and this is something, again, that is a very software engineering concept, how do the different components of law interact? How do they relate? What are the dependencies? If I change this library around how a search warrant works, or I change a definition here, what are the repercussions? What other pieces of the entire legal code are going to be affected? How do I identify those so that I can understand what might happen and think about the consequences? And again, this is something that it would be great to have as a tool where I can say, I want to touch this piece of code. What's going to happen? Or I want to know all of the different components that this law depends on. I want to know where all these definitions are coming from and not have to read through the law and hit a search engine to look up each individual piece of legal code, but just have that handy in a way that's usable and user-friendly. Next step, of course, would be quote-unquote automated testing. It's not likely to be feasible to test most laws in a real automated fashion, but it certainly is possible to write a test suite. It is possible to say, you are writing a law that's going to affect cameras. Well, let's look at every single context that cameras might be used on drones, smartphones, webcams, different resolutions, different contexts, video, audio capabilities, all of these different pieces. A lot of laws are written around one particular scenario. I don't want people using a drone to fly over and look into my house. And if you write something that's very narrow for that scenario, maybe it works. But a lot of times it's written in a way that is going to have an impact in many other scenarios that weren't thought of. And having basically a test suite to run through and hypothesize, how would this law work for this scenario? How would this law work for that scenario? How would this law work for something that I envision coming in 2-3 years that isn't real yet? Would really help laws to be more comprehensible and more robust. Code review would be awesome. Who wants to volunteer to code review all the laws? Anyone? No, I don't even want to volunteer for that. But it is something that would really help to actually get eyeballs on this who can think about it, again, from an engineering programmatic way. What is this actually doing? Is it good code? Is it trying to hide the ball? Does it have unintended consequences? Are they intended consequences and you're trying to hide the ball? How is this going to change as time goes on? This would be a really helpful project. I don't expect a lot of volunteers, but it's something where we have big pieces of code coming on. When there's the next major cybersecurity bill, maybe we can break it into, let's see, how many people in this room? Maybe 5 pages each, and we'll get about right. Anyhow, it's something where really breaking down the law and looking at it from an engineering perspective, again, from breaking it down into logical outcomes, would really help. And again, it might also help to explain to lawmakers, this doesn't actually do what you think it does. Security isn't something you can just turn off. Encryption, anonymity is not a perfect concept. All of these things that lawmakers think they understand, sometimes they don't. What would be nice is to actually have coding standards. It'd be great to be able to say, okay, you're going to write a law, here's what it looks like. You start with the definitions, then you have then you have your constraints, then you have your consequences, then you have your enforcement, so on and so forth. You write it in this style. Again, coding style saves a lot of time because you know where to look for things and you can read the code in a lot more intelligible fashion. Lawyers, that would be nice. It's hard both because lawyers are trained mostly to interpret the law. They're not trained to write laws. And so they're trained to interpret the massive cornucopia of different styles of laws that are on the books, and so they don't internalize any kind of standards whatsoever. And then if they do get to writing the law, some of them are intentionally writing the laws in ways that hide the ball. So I'm not going to win this battle, but it would be nice. And then, of course, talking about adversaries, we do have adversaries. A lot of times we are advocating for legislation, but just as often, maybe even more often in the coming years, we are looking at situations where we are opposing a bill. And maybe you're allied with us, but in various cases, there may be laws that are doing harm to your world, to your environment, to your friends, to your communities. And the engineering mindset can really help to flesh out and prepare for opposing, to play defense in this world, to understand exactly what the consequences of this bill are, to identify the scenarios where harmful consequences happen and enlist allies to oppose a bill, to mobilize real people by real world harms that will happen rather than bury everything in legalese and hope that nobody notices until it passes through. So that's going to be a very major effort for us in the coming years, I'm fairly sure, and we will be looking for support. So my future work is basically to try to figure this out. My time has been a little more constrained since I submitted this talk than I would have liked because the execution environment is changing rapidly, should we say. But I certainly want to figure out how can I continue to think about how can we use engineering thinking, mindsets, techniques, tools to make better laws and to understand what's being proposed and to push for changes, to push for amendments to kill bills that are doing harmful things. So I want to think about the tools that we can use that can help to understand what all the consequences of given proposed language might be. I want to think about how we can test suites. What's the basic set of groups, individuals, technologies, scenarios, whatever it may be that I want to run through any given law to say what's going to happen. Who is going to be negatively affected? If nobody, great, you've done a good job. If this group, then let's talk about what's happening here. I would love to enlist people to code review. I'm still working on that sales pitch. It's not good yet. If you can help me with that sales pitch today, that would be a wonderful win for me because I have not mastered it yet. And then test and iterate. We are going to be having legislative battles. We're already facing one in California around something that would amend CalACPA to exclude schools entirely. And I will be trying out the concept of really breaking it down into what happens, how do I spell this out, how do we enlist allies in a much more rigorous way, and then seeing how it goes and working from there. How can you help? I'm glad you asked. I am still working on this. This is very much a early stage concept. You can let me know what I can do better. You can ask me questions. You can find me afterwards. You can email me. And the ACLU is very much recruiting people of every stripe, but especially technologists who can support our work right now, who can give us feedback on what we can do better, who can help us build tools, who can help us build security tools for all sorts of people who are working with vulnerable populations and need to know that the people they're working with are safe, that they can communicate effectively, that they can mobilize, that they can do all the things that technology allows without surrendering the privacy and security of their most vulnerable members. So please contact me, and I'm happy to take any questions. Thank you.